In C++, the const keyword means that this variable can never be reassigned. So in this first example, let's see what happens. Let's first take the int a equals 42 part. This will create a new int variable. Its name is a, and it has a value of 42. It's a const variable, meaning this variable can never be reassigned. So if I later try to do a equals 41, this would not work. I would get a compile error because I'm trying to reassign something that's const. The second line of code, int const b equals 42. So this is the same thing as the previous line, except I've swapped the order of const and int. It turns out that these two things are identical. I can say const int, or I could say int const. Either way is equivalent. And the result would be, again, a variable of type int, this time called b, but same thing. And its value is 42. And again, this is const. It can never be modified. So I can do const int, or I could do int const. Let's look at how the const keyword relates to pointers. On this first line, int a equals 42, I'm creating a new int called a, and its value is 42. On the next line, I'm creating pointer1, which is a pointer to an int that's const, so a const int. So int pointer called ptr1. And remember, this ampersand represents the memory address of a. So then ptr1 is pointing to this object here, but it's a const int pointer. It's a pointer to a const int. So the const int cannot be modified. So this pointer, it cannot modify a. I can reassign it if I want to. So I can reassign ptr1 to point to a different int object, but I cannot modify whatever it's pointing to. On the second line, int const star ptr2 equals ampersand a, this is doing the same thing. Again, I'm creating a pointer that points to an int, but cannot modify whatever it's pointing to. I can reassign it to point to a different int, but I cannot modify what I'm pointing at. So this one, it looks the same, ptr2, it's int pointer, pointing to this object. Now for the trickier one. So int star const ptr3. So this, I'm creating another pointer to an int. Oops, ptr3. And again, it's pointing here. But the const is now on this side of it. So what this means is that I cannot reassign my pointer. So it's a const pointer. So my actual pointer itself is const. In these cases, I had a non-const pointer pointing to a const int. So I could not modify what I'm pointing at, but the pointer itself was not const, so I could reassign it as needed. The pointer itself is const. It's a const pointer, so I cannot reassign the pointer, but I can modify the object I'm pointing to. I can modify a. I just can't reassign this pointer to point to anything else. So then in this example, it's a pointer to a const int, but it's actually also a const pointer. So it's a const pointer, meaning it cannot be reassigned. This part, const pointer, this const means cannot be reassigned. And it's pointing to a const int. It cannot modify whatever object it's pointing to. So let's say, I'll draw it here. ptr4, it's a pointer here, int star, but I cannot reassign it, and I cannot modify the variable I'm pointing to. So put it generally, if I have something star and then const, so I have either const type or flip these two around, and then const and the variable name. This one makes it a const pointer. It means I cannot reassign. And this const means that it's pointing to a const variable. So what it's pointing to is const, which means I cannot modify what I'm pointing to. It's pretty tricky, but just remember, if the const is on the right side of the star, I can theoretically modify it, but I just cannot reassign what I'm pointing to. If the const is on the left side of the pointer, I could theoretically reassign what I'm pointing to, but I cannot modify whatever I'm pointing to. If it's on both sides, I can't do either. I cannot reassign this pointer, and this pointer cannot modify the object it's pointing to. Let's talk about how const can be used with references. In this little example, let's say I create int a equals 42. So that makes a variable of type int called a, sets its value to 42. And then on this line, I'm creating a const int reference. So ref1, just even if we didn't have the const, ref1 would be another name for a. So we would have ref1. But what does this const keyword here mean? Const with the reference means I cannot modify the variable through the const reference. So in this case, if I were to do something like a equals 21, this would be fine. Through a, because a is not const, I can modify this variable here. But if I were to do something like ref1 equals 20, this is not allowed. This is not allowed because even though this variable in general could theoretically be modified, ref1 is a const reference. So ref1 cannot modify this variable. I cannot modify this variable through ref1. On this third line, ref2, all I've done is swap int and const, and this is totally fine. These are the exact same thing, so these are equivalent. I can put const int or I can put int const. Either way, this creates a const reference to whatever variable this is. So in this example, this would make even yet another name for the same exact variable. This name is ref2. And again, just like in this example, I cannot modify this variable through ref2. I can only modify it through a because a is not const. So I can have const references to non-const variables. And if I have a const variable, any references to that variable must be const references. The const keyword can also be used with functions. In this example, I have a student class which has a private instance variable called name of type string, and it has a public constructor that just initializes the name instance variable. And I have this getName getter function, which I've defined here. And notice that I declared it, and I put this const keyword at the end. So what does this const mean? This means that this function cannot modify my object. If I call this getName function, my object must not be modified. So in this example, so I've actually implemented it here, all I'm doing is returning the name instance variable, so I'm not modifying my object in any way. We cannot do any assignments to our instance variables, so we cannot assign instance variables. And also, if we want to call any other functions, we can only call other const functions. The reason for this is that even if I call another function, if that other function isn't const, I've now modified potentially my object. So that defeats the purpose of the const here. So this const here guarantees us that this object will not be modified after calling this function. So it cannot modify anything, and it cannot call any other functions that can modify stuff. So it can only call other const functions.